Okay, let me explain it one more time then. See what happens. Let's say that you have x1, x2 and x3, x4 price, it could be price, torque, mileage, something, I'm not sure. And then you have a lot of data here. Let's say you have 10,000 records. And then using elbow curve, you have used different values of K. And then you have identified that K equal to 3 would be the optimum value. Once you have done the K equal to 3 as an optimum value, you will come up with the final clusters. And you will notice that in this cluster, all the data has very high price value. X1s are very high. Let's say X1 is price. Then you will understand that in this cluster, you have all those cars which are very costly. So these are premium cars. In these cars, you will have the cars which are very low price, so low budgeted cars. In this, you will have all the cars with price and mileage very economical. So these are economical cars. You can actually tell that using unsupervised learning, you have got 3 classes. And now these 3 classes can be used for supervised learning, saying that this would be a Y. This data belongs to premium. Say this is premium 1, 2, 3. So premium 1, 1, maybe 2, 3, 1, so on. So now what you are trying to do is, you have using unsupervised learning, you have found the patterns. From those patterns, you are deciding your output, how many classes you can have. And then on this, you can run your predictive analytics for training your model. And whenever there is a new data which comes in, you can decide that this data goes under which cluster or which class. So this is how what we are trying to do is, we are trying to improvise our model by combining unsupervised learning and supervised learning both. Okay, so it will go with the older values. See, once you have used this clustering analysis, what you are trying to do is, using this clustering analysis, you have coming up with the outputs. And then I'm just telling, it's not necessary that you have to do it. You can use this outputs as used for supervised learning, and then on this data itself, you can split the data again into training and test data set. Okay, and then you can check whether the data is overfitting or underfitting. If it is neither underfitting nor overfitting, then you can use this supervised machine learning algorithm for predicting the output for a new data. So for example, you have coming up with very new raw data, say different values of X1, X2 and X3, X4, and you want to predict that this data belongs to which class of vehicle. Then you can predict. Okay, great. So I want you to come up with the answer for this first question. How does the similarity would be calculated for if the data is categorical in nature? I think we have discussed this. This answer would be in the similar lines. If you remember the discussion what we had in KNN, the answer would be lying over there only. So you can think on the similar lines and you can come up with the answer. How do you calculate the similarity if the data is categorical in nature? The only difference is KNN would be having the output also, but while calculating the distances, output would not be considered, right? Here also you can think on the same lines. Anyways, there is no output in this unsupervised learning data set. How do you calculate the similarity? See, there are different ways of calculating the similarity. I have just told you about Euclidean distance or absolute distance formulas, but there are a lot of different ways. What you can do is, you can also use cosine formulas. If you remember, the dot product, A dot B is equal to modulus of A modulus of B into cos theta. So for example, let's say that vector product A dot B is equal to cos theta. And what is cos 0? 1, right? So what does this cos 0 means? That A and B are lying very near to each other or overlapping each other, A and B vectors, right? So the angle between vector A and vector B, if it is 0, then the value of cos 0 would be 1. So based on this cos theta values, you can actually come up with a similarity score also based on this cos theta values also. Lower the theta values, that means there is a very high similarity between A and B. Higher the value of theta, that means very low similarity between A and B. For a value of theta to be higher, this value has to be lower. right? Because we know cos 0 is 1, cos 90 is 0. So higher the value of theta, low similarity, low value here. Lower the value of theta, high similarity and high value here. I'm not sure if you're able to recollect this, guys, this formula, vector product, dot product. So you can use cos theta of this cosine rule also for calculating the similarity score. It's up to you which formula you want to use. But there are a lot of formulas, okay? Now implement this k-means for the given data set and come up with the business insights. So I think you will get the data set also from the team. Okay, so this was all about k-means. In the next session, we'll be looking for hierarchical clustering, and before going into next session, we will look for the Python coding here. Okay, how does the Python coding looks like? So again, I will not be running anything here. If you want to note down, you can note down few points here. So same thing, NumPy, Pandas, Matplotlib, again I don't have to tell all those things. NumPy is used for doing exploratory data analysis. Pandas is used for playing around with the data frames. Matplotlib is used for visualization. Skill-Learn is used for machine learning inbuilt algorithms. Okay. Now just imagine that this Skill-Learn, what we are looking, it has all the functions for which are used for machine learning, right? So in this Skill-Learn, if you remember, we had linear regression, logistic regression, what all things we had in this. Now, unsupervised learning is also in under Skill-Learn itself. So let's say this, under Skill-Learn, we have a function by name cluster, and in cluster, we have a function k-means. So we have imported k-means here, okay? So most of the steps are repeated, guys, okay? But you have to always keep in mind that you're doing exploratory data analysis. So data frame has been created using pandas, and then you have imported some CSV file. I already had a CSV file by name k-means, and then so let's run this later on, but first let's understand this. Using this describe function, you know that we will get the value of q1, q2, q3, q4, min, max, count, min, mean, mid, everything, like a lot of different parameters we will get from here. And then again we are assigning this k-means to a particular variable with number of clusters equal to 3. Okay, now I'm printing km, and then I'm using y as for predict between age and income, because okay, let's run this. So what you would notice that this CSV file, had 3 features by name, age, and income. So what I have done, I have built my k-means on with 3 cluster, and that too only on age and income. Okay, because this name would be like not useful for our analysis, so I'm not using name in our analysis. I'm just using age and income. And here y is not our output, y is number of clusters. Now if you notice, I have done a clustering analysis, and then I have predicted the y. What do I mean by predicting y? I'm predicting that in which cluster this data point would go. For example, the first data point is going under cluster 2. Second data point is going under the cluster. So how many data points we have? 22. 0 to 21, right? So 22 data points we have. And these 22 data points now, some of them are going under cluster 2, some of them are going under cluster 0 and some of them are going under cluster 1. Because we are using 3 clusters, we have only 3 clusters here, 0, 1, 2. Okay, now let's assign these clusters to our data frame so that we can visualize it in a better way. So what do you notice here? This and this and all other ones, there are no ones apart. Yeah, this. So all goes under 1. And if you notice, very high income people are going under cluster 0 and with very low income are going under 2. So what you are trying to make it here is, you are trying to segregate the people or make a cluster out of these people based on their age and income. Now it's very clear that in cluster 0, we have all the people with very high income. In cluster 2, we have people with very low income. In cluster 1, we have people with moderate income. Okay. Now, let's create 3 data frames here. Let's try to create 3 data frames out of this. And what are those 3 data frames? Do we have any measure to assign an output class? What do you mean by that?
Hi sir, I mean we are saying that output 2 is having higher income, output 1 is having mid-level income, output 0 is having low income. That is based on our visual decision, right?
Yes.
Can we have some measure which can just say output 2 is higher, output 1 is mid-level, output 0 is low?
Yes, you can actually, you can find the mean of the income based on this by filtering the values of cluster. Okay, for example, if you're finding the mean of income, say with cluster equal to 0, then you will notice the mean of the income would be very high. And then you can calculate the mean with cluster equal to 1. You can find mean of income for cluster equal to 2. Okay, but yes, you can also visualize that in the plot.
Okay.
Yeah. So now what I'm doing is I'm just trying to create 3 data frames here because we know that this data frame has all the 3 clusters. So I'm just trying to segregate this data frame into 3 data frames. Okay. Now you would notice something important. So what I'm trying to plot here is when the clusters are equal to 1, I'm just trying to plot the graph here. Okay. So by plotting this graph, you come to know that this cluster has all the data points with ages of around 35 to 40 and with very high income. Okay. Similarly, you can plot for other 2 data frames and then you can understand in a better way to visualize it. Okay. But then there are few things which we need to understand apart from this. Okay. For example, okay, now the first thing which we need to understand is the scale of age is different from scale of income. So when you try to draw the cluster plot, you can do at your end, but when you try to draw the cluster plot, you would notice that there would be some inconsistency. Okay, you would notice that when you draw the plot with this data. Why? Because the scales are different for age and income. And if you remember, when your k-means and knn, this kind of algorithms are based on distance formula, right? And your distance would be completely based on the scales. So for example, if you're calculating the distances, your distance would be highly influenced by the income values rather than age value, because your incomes are very high scale value. So if you remember, I told you to, in these cases, we have to scale down your columns to a values 0 to 1 or using z-scores, it's up to you. So what I am doing here, I am coming up with a new definition on new function. And what I am doing is, let's say value, observation value minus the minimum of this divided by maximum minus minimum. Do you remember that formula which I have told you? X minus X min divided by X max minus X min, so that you can scale the values of a feature. So that is what I'm doing here. So I've defined a function, min max function, and that min max function, I'll be using that for both age and income. Okay, I'll be implementing that function on both age and income. Okay, and then I will come up with a new age values and income values. So let's do that. So it's important, guys, whenever you are trying to use this distance formulas, no, it will be good if we scale your all the features in a consistency manner. Okay, let me remove this. So what you notice here is age, income, and the clusters, and then you have come up with a new two features which are based on the formula this. Now all the values of age and income would be between 0 and 1. So now once your features are consistent, now if you do clustering, you will get better results. What I meant is, let's again implement k-means on this and then come up with your new y. Okay, and then assign that new y. Okay, now these are your serial numbers, these are your names, this is your old age, like this is your age and income, and this is a cluster which you have created based on this age and income. Now these are new columns or new features based on age and income, converting these numbers into the range of 0 to 1. And once you have a consistency range for both the features, I'm coming up with a clustering onto this new two features. Now if you notice, this would actually give a better result for us. Okay, how I am telling that? Now I'm coming up again with new 3 data frames. Okay, and then I'm assigning that into plots. Okay, and then I'm creating the cluster centers algorithm, and then I'm plotting it at the end. You don't have to worry so much. What I'm trying to do is I'm trying to segregate this data frame into 3 data frames based on this cluster values, new cluster values what we have. Now if you notice, there are some values which are here. Okay, there is something wrong here while plotting. This income should have not come here. Anyways, so all the 3 clusters are lying here. It's because of this income value we are not able to understand the graph in a better way. Let's remove that income. I don't know why is it coming. This is here. I have to comment this also. Okay, now let's remove this and now run this again. Yes, now if you notice, all the values are between 0 to 1. right? All the income values and age values are 0 to 1. And if you notice, this is one cluster, this is second cluster, and this is third cluster. Okay. And then this is the stars are centroids. Okay. Now it looks very good that for this star, these are the data points for this cluster. For this cluster, these are the data points, and this is a centroid, which looks very consistent. Now what you have to do is at home, try to do the same thing for the old data. Okay, you don't have to print all this. It is just telling when we are printing this, that means we are getting the centroid location. You don't have to do all that. If you want to know the centroid location, you can do in this way. Variable dot cluster underscore centers underscores cluster. Okay, you don't have to worry that much. If you want to look at the center coordinates, then you can. Otherwise, you can, if you want to plot, just plot it in this way. Okay, so plot dot scatter. What I'm trying to do here is, here I have plotted those 3 data frames, and here I am plotting those centroid values. Okay, that's the only thing which I'm doing here. And this, by this I'm coming up with the legends, and this show command shows the graph to us. Okay, it looks very good, right? Now let's try to do the same thing, or maybe what you can do is, let's try to do the same thing here with this clustering analysis. When we are not scaling your data, let's try to do the same thing. Okay, let's see what happens. Okay, now what I'm trying to do is I'm trying to create the cluster with old data without scaling the data, okay, in consistent format. Because if you remember, this age underscores min max and income underscores min max are the new features for us to scale down your data in the range of 0 to 1. Let's not scale down the data. Let's see what happens. There is something wrong, it seems. The feature name is this. Right, the feature name is this. Okay, now if you notice that your clusters are not looking very consistent and your data points are also not very good. These red points belong to one cluster, but this green points are here, these green data points are here also, and the cluster is somewhere else, somewhere here, and then the red data points are here, red data points are here. So what I'm trying to tell here is, you will not get the results efficient when you have a scaling issue. So that's the reason first you have to scale down your all the features to a particular range 0 to 1 whenever you are dealing with such algorithms which deals with distance formula. Okay, so now comment this and then run the previous one. So now if you see, it looks so consistent. This makes sense, right? So did you understand the difference, guys? What happens if you do not scale your features to a particular scale? How can you go wrong? Because your distance formula would be influenced by the income value, right? So did you understand this, the difference between the earlier old results and the new results without scaling and with scaling? Great. Now let's look into elbow curve. So I am giving the value of k which ranges from 1 to 10, but anyways, as I told, 10 would not be included from your Python basics, and 1 doesn't make any sense, but I'm just using it for the based of calculation. And then I am making a new empty list for sum of squares of errors. Okay. And then I'm using for loop with different number of clusters. I'm trying to fit this k-means algorithm on age and income, that too on the scaled values. Okay, and then I'm printing it and then plotting the values between k and sum of square errors, and then I'm displaying that plot. So this is the one plot of clustering and this is the other plot. So now can you tell me what could be the optimal value of k by looking at this plot? So the value of k would be 3. So this is what I wanted to tell you guys. And k-means is highly, like most of the people use k-means in the organization. So I always tell this, if you're going for an interview, you should be proficient in at least 2 algorithms in and out. And then you should have the knowledge of all the algorithms, but you should be perfect in at least 2 algorithms, because in interview people might ask you what 2 algorithms you have used the most. So, and if you tell k-means and linear regression, then they might ask very in-depth questions in k-means and linear regression, then you should be able to tell all the answers. So my recommendation for you guys would be understand all the algorithms, but before going for an interview, be proficient in at least 2 algorithms, so that in the interview you can tell that these 2 algorithms are the ones which I have used at most of the times. And then when they ask questions on those 2 algorithms, you should be able to tell the answers. Okay, making sense? So today I have one of my favorite puzzles. Please, I would request you, please try the puzzles as much as possible, because this will improve your analytical skills. You have a 10-digit number. Okay, you have to come up with a 10-digit number such that understand this question, this could actually lead you into loops under loops. Okay, so you might have to try really hard, and you might have to come up with a new number, and then you will think this number is wrong answer, then you will come up with a new number, and then you will think this is also wrong. You will be stuck in a loop, so you will have to do a lot of analysis here. The first digit of this number indicates number of zeros in this number. The second digit indicates number of ones in this number. Third digit indicates number of twos. And then last digit would indicate number of nines in this number. So you have to come up with a 10-digit number in such a way that its first digit should be a count of number of zeros in this big number. The second digit should indicate number of ones, the count of ones in this number. And similarly, last digit should indicate number of nines in this number. Did you understand the question? It's a very highly analytical question, and I would be really appreciating if you can solve this puzzle, guys. So I always recommend try this puzzle. This puzzle is very close to my heart, and then I would say please do not look at the Google. Always try the puzzle at your end and then come up with the answer. because that will improve your analytical skills. Okay.